award and 100 level students in various institutions. I notified you earlier about the class today, and we'll be looking at it in a moment of time. Yesterday we looked at organic chemistry, and quite a good number of you saw the little thing I taught yesterday. The class will continue at another time. For today, we'll be looking at calculus. Actually, the word calculus is attributed to two persons, basically Leibniz and Isaac Newton. These two persons are referred to as the father of calculus. And it's important you know the origin. Okay, now the limit we are considering before differentiation is important to know limits. Now, what does the word limit means, and what are the properties of limits, and then what are the way of evaluating limits? You are given a particular question. For the secondary school students, it's very easy to evaluate limits, but for the higher institution students, in evaluating limits, you must consider the nature of the limits you are given. And so I will be telling you the various ways by which limits can be evaluated. Okay, so if you do not know a particular way, for example, you are given a question that demands you using L'Hopital rule. If you have not heard about L'Hopital rule, how are you going to evaluate that limit? It will be difficult to evaluate. So it's important you know the various ways by which limits can be evaluated. Now, limit is actually a kind of function that tells you that this thing is approaching a particular value, approaching the properties of limit. In looking at the properties of limit, I won't be looking at all the various properties. There are so many of them that we have various properties of limit. Now, but I'll be looking at just few properties of limit because of the limited of time and because of the focus where I'm actually going in the class. I don't want to spend all the time on limits. Now, number one, if you have lim, we normally shorten it as lim. You have f of x, now here, and then you have plus g of x, and then you have it. The lim is outside. Now you could evaluate this limit by having lim. You place it by the side. What this means is s is approaching or tending. We use the word approaching or we use the word tending. S is approaching or tending to A. Now that will give you now f of x plus minus. Then you place the limit as if you are using this to open the bracket, and then you have the g of x. And with that, you have evaluated that limit. But if you do not place the limit by the side of the g of s, it is wrong. We have another limit that's a limit as x tends to infinity. 1 over x will be tending to what? To 0. As x is tending, approaching infinity, 1 over x will be tending to 0. And it's important you know that. Number 3, limit as x is tending to 0, your sine x over x will be tending to 1. Limit as x tends to 0, your sine x over x will be tending to 1. What does that mean? X or sine x rather is an odd function. Now I'm coming to that later. So limit as x tends to 0, your tan x over x is also tending to 1. Number 5, limit as x tends to 0, your cos x will be tending to 1. Somebody may want to ask, why the disparity? That is, why is the difference? Why is this having x here? For those who are not familiar with things like this, for those who are familiar with it, they will know what has actually happened. But for those who are not familiar, you are wondering, this one is having x, this one is having x, and there is no x beneath cos x. It should be noted very quickly that sin x and tan x are called odd function. Now, the simple way, or the simplest way, or the easiest way to define an odd function is to say, for example, that if you have f of x equals to minus a, it will give you minus a. F of minus x will give you bracket minus a. That's an odd function. Example of an odd function, you could have a, you could have s cubed, you could have tan x, you could have what we call sin a, you could even have cosec a. All these are classic examples of an odd function. You could see something here that the minus in this function is reflecting out there, and sin and tan x are good example of an odd function. But look at an even function. For an even function, you see now that for an even function, the case is not going to be so. I told you this is just the easiest way. There are other ways you can identify an even function and odd function. Do you observe something here? In the case of even function, the minus x in the bracket will not reflect out there. And a classic example on that is your s squared, is your x4, is your cos x, is your sec x, and so on and so forth. I am sure that's clear. In case you're not following, it shows that if you are not following, it simply means that there are things that either I'm too fast and you're not getting it, or there are issues I need to clear up. I like to go over it again quickly. I talked about limits, and I said, talking about your calculus, Isaac Newton, Leibniz, and then we talked about properties of limits. And then these are the properties on the board. These are the properties. So there are so many of them. We have sum, we have division, we have product, we have so many. We have quotient and all of that. And but we are going to make use of them. Now there is another property of limit, but time will not permit. So quickly, how do you evaluate limit? How do you evaluate limit? Now, there are ways of evaluating limit. So I quickly look at ways of evaluating limit. How do you evaluate? Evaluating limits. I'm sure we're following. Number one, limit can be evaluated by direct substitution. Direct substitution. Number two, limit can be evaluated by factorization. Factorization. Three, limit can be evaluated by what we call rationalization. Rationalization. Don't mind me speaking phonetics. Okay. Now rationalization. Number four, it can be evaluated by dividing. You can divide by dividing with the highest degree of the variable. The variable you are given. If, for example, in an expression you have 3x cubed minus 2x squared plus 3x plus 1 over 3x raised to power 2 minus 1, and then x is tending to infinity, that's when you make use of this value. In that case, you're going to divide both numerator and your denominator with your s cubed. Very simple. Number 5, limit can be evaluated by the use of L'Hopital rule. L'Hopital rule. Now, and then we have another one called perturbation. Limit can be evaluated by the use of perturbation. Let me quickly explain. Now, assuming you are given an expression like this, limit as x tend to 2, x squared 4 over x minus 2. Now for an average secondary school student, if you give an average secondary student this, you know what the student will do? The student will see what you have done as an insult. You are asking the person to evaluate x squared minus 4 over x minus 2 as x is approaching or tending to 2. The person will feel, uncle, teacher, mister, why are you giving me such a simple question? And the person will substitute x directly into the expression above. And then you will put 2 here. This becomes 4, and then this is minus 4. So you have 0 up, and then put 2 here, you have 0 up, 0 down. And the person will say, sir, 0 over 0 equals to 0. Wow. Is 0 over 0 equals to 0? For those of us who are watching, is 0 over 0 equals 0? Never. 0 over 0 is not 0. It is called indeterminate form. It is called undefined. Okay, and in evaluating limit, I'm going to tell you certain things you must avoid. Okay, so we cannot do direct substitution in this case. Why? It is leading us to indeterminate form, so we cannot use direct substitution. So you switch to the next one. You ask yourself, can it be done through factorization method? Let's find out if it can be done. So I have x and then 2 here, and then factorizing this now, difference of 2 square, I have x here, cancel this, so you have limit, and then you have 2 here. This is x plus 2 in place of x. Put 2 there quickly, and then you have 4. Can you see something very quickly here? That when we factorized, we got the correct thing. When we did the factorization. Something that we couldn't get when we used direct substitution, we got the answer when we employed factorization method. You see now? So you will also be given some question that will not be used, that you will not be able to use direct substitution. Neither will you be able to use factorization. The method that will be appropriate in that case will be rationalization. I give you an example of such. For example, 1 minus cos x over x as x tends to 0. I like to tell you quickly that direct substitution will not work. Neither will factorization method work here. What will work here is called rationalization. You got to rationalize it. And you know there are people that you've been taught in sub that you can only rationalize the denominator. That's not true. When you get above your secondary school, you will know that something like this can be rationalized. What do I mean? If I want to rationalize this, I am going to have 1 cos x over 1 cos x, and then multiply by, you have x here, 1 cos x, and then 1 cos x. Then I can now begin to evaluate. So you can do something. If that will give you the answer, you can go ahead. But then I like to take you back so that you understand what we are doing here. The question we solved just now with factorization method that gave us 4. My cameraman, please make sure that my people are seeing what I'm doing. So now there's a method I call L'Hopital rule. What's L'Hopital rule? L'Hopital rule simply means that an expression is given to me, and then in that expression I'm not able to substitute directly. But in L'Hopital rule, what do you use? L'Hopital rule states that you should keep differentiating the expression you are given until indeterminate form is avoided. What does that mean? That's sounding too high, right? Yes, for the YX, I'm sorry, but for those in the higher institution, I'm sure they got the message. The message is saying is that this is an expression. If you substitute 2 into this place, what do you have? Indeterminate form. What do I mean? 0 over 0. And 0 over 0 is not 0. It's indeterminate, undefined. In that case, what do I do? L'Hopital rule says differentiate this expression and substitute the value you are given. If it gives you an answer without going through an indeterminate form, you are good to go. So can I quickly demonstrate that to you? Are you with me? Beautiful. Okay, so differentiate this now quickly. You have 2x. Differentiate 2, you have 0. You have, of course, that's a constant. Differentiate x, you have 1. Differentiate 2, you have 0. And then you were given what? 2. Put 2 in place. Then you have 2 times 2. That's 4. So the answer is 4. The answer is 4. And remember when I used factorization method, I got 4, right? That's to tell you that no cheating. Once the right thing is done, you are arriving at the same answer. Beautiful. Okay, so perturbation method, you can also make a little research on that yourself. Now, those are the methods that we can use in evaluating limit. I'd like to give you some questions now. If I give you some questions, now let's look at this question. Evaluate the following limits. One, limit as x tends to minus 1. Number 2, limit three. Now on your own, I will cancel that you solve question. The important thing is to understand what exactly I am doing. Let me put one more question quickly. This is limit now as x is tending to infinity. You have s raised to power 4, you have s raised to power 2, you have s raised to power, okay, just x, and then you have 1 over, okay, can I put 2 here? Let me put 2 there, and then you have x raised to power 3, and then you have 2x squared, and you have 1. Now, in this case now, x is tending to infinity. Infinity is like a large value that you cannot really quantify. Okay, let's quickly go. Now, to solve number 1, oh, I missed something. Quickly, let me remind you something. Now, what am I to remind you now? In evaluating limit, avoid the following. 1, avoid infinity divided by infinity. They are referred to as indeterminate. A constant divided by 0. Friends, YX students, higher institution students, a constant divided by 0 is not 0. It's indeterminate. It won't give you 0. But 0 over constant is 0. That's beautiful. That is, you cannot say 10 divided by 0 is 0. It won't give you answer. It won't give you 0. It's not possible. It's undefined. It's indeterminate. But when you have 0 or you have a constant that you are good to go. So infinity dot infinity indeterminate. Okay, you must endeavor to avoid 0 over 0. Avoid all this when you are evaluating limits. Avoid this. So when you avoid this, then you are good to go. There are others that you are supposed to avoid. Now, let's solve now. So for question number 1, my friends watching will tell me what the answer can be. Now, what should be the answer? What do? I will test. I don't know the various way by which limit can be evaluated. Put -1 here quickly. 2 minus 1 all square 1, and then you have -1 square. Then you have -1. So you have -1. Here you have 2, 1 and 1, and then you have 1 here plus 1. And then here you are going to have -1. You are going to have plus 2. You are going to have -1, you are going to have 2. Remember, -1, you are owing 1 naira. Another -1 here, you are owing another -1 naira. That's -2, that's owing 2 naira. Then you have plus 2, you have 2 naira. -2 plus 2, that gives you 0. And then you have 2 here. This is not indeterminate form, this is 0. The answer is 0. Now, if you solve this for your teacher and your teacher marks it wrongly, that teacher should be arrested. Yes, because you are not contravening any rule. The rule says that you can only avoid this if it will lead you to indeterminate form. We didn't get indeterminate form, so this should be accepted by your teacher. I'm sure you're following. Okay. So let's go to the second question. For the second question, you are having a situation like this where you need to employ rationalization method. So can we use rationalization method? Let's say before you use that, substitute directly into this. If we substitute directly, we have 1, you have cos 0, you have 0. Okay, automatically this will give you 1. Cos 0 is 1, you have 0, 0 over 0. Can I see the problem? This is exactly what I was telling you. You need to avoid it. So it means that this question cannot be solved the way we solved the first one. We cannot solve this in that manner. So you think of another method. We cannot factorize this. It means that it's either we use L'Hopital rule or we use rationalization method. So to rationalize it, you have 1 cos x over L. Rationalize the numerator. So you have this over this, limit as x tends to 0. So to do this now, quickly my friend, you have this multiplied by this, which will give you cos square x, then you have x 1 plus cos x. So that's what you have there. That's what you have there. Okay, please do follow very quickly as we now. So you have this limit as x tends to 0, we have 1x squared over x bracket 1 plus cos x. Now, for those who have probably heard about trig identity, there's what we call trig identity. If you are used to that, but if you are not used to that, sorry about that. I'm not teaching trig today, that may be another day. But in trig, we have a property in trigonometry that says sin square x cos plus cos square x is equals to 1. If you make cos square x subject of formula, or you make this subject of formula, you're going to have 1 this. So it means with this now, I can bring in this expression. So limit as x tends to 0, so my sin square x over x and then 1 plus cos x. And then I ask myself, I want to split this. So I say limit as x tends to 0, split this. Okay, you have this over the dot. Limit, again, please listen carefully. For the campus students, your lecturer will have the right to mark you wrong if you do not place the limit beside this. What I'm saying is, if you quickly, in fact, remember sin x over x is 1 from the property of limit. I told you that. But it only makes sense to the lecturer and to anybody, to any mathematician, when you place the limit beside it. Except that it does not make sense to us. It does not make sense to anybody. It does not make sense to any mathematician. It has to be placed beside it. When you place it beside it, then we can infer or refer or remember or recall or recollect that sin x over x is equals to 1. That makes sense to us then. So you have sin x 1 plus what? Cos x. So this is 1. Of course you know that now. And then within the 0. So we have sin 0 here. And then look up now. This is 1. What is cos 0? Cos 0 is 1. So you have this 0. What do you have here? 1. You have 2. The answer is 0. Beautiful. Can you see now? It gives us 0. Now, I want to verify something. Let's see whether there's a Joe in mathematics. I want to use another method. If I don't get 0, we're going to crucify this thing. So let's use another method. If it gives us 0, so we have a method. So let's go. I'm using now in this case L'Hopital rule. the rule that says that we should keep differentiating until we're able to avoid indeterminate one. If you differentiate 1, you have 0. If you differentiate cos, you have minus sine x. If you differentiate this, what do you have? You have 0, right? If you differentiate x, you have 1. I'm sorry, you have 1. So in that case, what happened? You'll be having here, you have a 0, and then you have 1. That gives you what? 0. Beautiful. So if you really follow, you clap for yourself to have gotten that. I'm sure that's very, very clear. We use rationalization, we got 0. We use L'Hopital rule, we got 0. That's to tell you that there was no rule being contravened by the tutor. And so long you follow the right thing, you will get your answer. So we solved the number 4 question. Oh, that's the question here. The question here is talking about x is tending to infinity. Please, this is so important for you to listen. This is 2. Okay, this is 2. Now, you have your s raised to power 4 plus 3s squared minus x plus 2 over s cubed plus 2s minus 1. How do you go about questions like this? Because this is like not the same thing. There's a property of limit I'm going to employ here. For those in the university, or for those in engineering sciences and all of that, and this concerns you so much. To do this thing, what do? You look at this question. Whenever x is tending to infinity, we employ rule number 4 that says dividing by the highest number of the variable of x. That's what you do. So how do I go about that? So you have x tending to infinity. So you have x now. You divide it by the highest variable. Question quickly, what's the highest variable here? The highest variable is what? 4. The one that asks. So you divide both numerator and your denominator by that quickly. So simple. So simple. Okay, so you have x, you have x raised to power 4, you have 2, and then you have s raised to power 4. That's numerator. Come to denominator, you do the same thing, exactly the same thing, and then you have 2s squared over x4, and then you have what's there? Okay, minus 1 over x4. Remember, now, here is limit. You got to pay attention. As x, this is 1. Then, limit. As x tends to infinity, you have 3 over, that is 2 cancel here, you are left with s squared. Please follow. This is squared, this is 4. 2 goes here, and then you are left with 4. And then here, 1x here, and then 4 here, you are left with 3. And then here, you are left with just the 4. But then, if you do it without placing the limit by side, it will not be correct. So you have to place the limit by the side. So 1 over x cubed, and then limit as x tends to infinity, 2 over s raised to power 4. And then coming to this, we have 1 over x, limit as x tends to infinity. And then you have this is 2, and then this is s raised to power 4. So place the limit by the side, so it will only make sense when you place the limit by the side. So then you have limits here as x tends to infinity, 1 over s raised to power 4. Okay, so you have that. Now here's the property I like you to pay attention to. This property was not stated before now. Now, whenever x is tending to infinity, a constant. Whenever x, please pay attention to this, is tending to infinity, a constant divide by infinity. That is, put this infinity. Time will not allow me as I bring the teaching to a close. I'll put this infinity here. Okay, let me do that very quickly. Just okay, do that yourself. Put this infinity here. Put it here. Put this infinity here. All that will be giving you 0. It's a property. It's a property that you need to know. So it's a property. So here you have 0, and then okay, here is 0, and then here is 0, and then here is 0, and all that. So when I was still getting indeterminate because I'm going to be having 1/0, which is indeterminate, meaning I cannot use. So the question was not properly looked into before being solved. So because it's giving me now indeterminate form. Now let's assume, please quickly look up. Let's assume this x was the one down and the 0 was the one up. The answer could have been 0 and would have marked it. So in this case now, you could use Laopito. Now the bottom line is this. When you are given the question in limit, look at the question. Okay, can I use direct methods? Can I use factorization? Can I use Laopito rule? Can I use perturbation? Can I use rationalization or direct substitution? You check off. Now, if you want to use direct substitution, make sure you avoid indeterminate form before you can think of any other method. So we're going to bring the teaching to a close today. I will not be able to go into differentiation. So tomorrow we are going into differentiation. I will notify you online when I'm coming for the differentiation class. I hope if I'm fast enough tomorrow, I will cover differentiation and integration. But let's do it systematically, and then we'll still be coming up with physics and other chemistry. Make sure you follow up on what we're doing in the next video. God bless you.